All right, lab 15. Hopefully this is going to be a surprise to no one. In this one, you need to finish with contains, delete. Ooh, I have delete and remove. I think there's only one of them. Good, there's only remove. So go ahead and finish up the remove function, which we started in class. And hopefully you'll be able to finish that one up for this lab. And then we have two more functions, exists in range and count in range, which we will talk about in a bit. This is part 2, so obviously it's an extension of part 1. Don't start this one until you finish lab 14. It's going to be pretty difficult, I guess. Or you have to do most of the work of lab 14 before you can do this one. All right, you have a binary tree node. You can call it whatever you want. You can BST node like we did. Copy constructor like beforehand. Put and height should be the same. This time I changed it to contains instead of search. So this time it just returns Boolean if it contains the value. If that const is really messing you up, you are allowed to delete it, but it shouldn't, because contain shouldn't remove anything. Remove is going to be the delete function we talked about beforehand, where you had your 4 cases. We went through the first 3. But just so you know, returns true if the value exists and was removed. Make sure you do remove it, because I will be testing for that. And then otherwise you just return false if it's not in the tree. Exists in range. In this method, return true if and only if there is a value in the tree greater than or equal to min or less than or equal to max. In other words, it returns true if an item is in the range min to max. So if there is a value in the tree between these two. So let's go to the picture. Is there a value between 5 and 14? Right? There's a 7. Let me make this a little more complicated. Is there a value between 4 and 16? Yes. 7. 5, 14, and 7 are all between 4 and 16. Is there a value between, I don't know, 5 and 6? Oh, I'm doing inclusive, so that would be the 5. Let me change that question. Is there a value between 15 and 18? No. Okay. So there's a brute force way to do it, where you just keep looking and you check each number. I am going to ask you to think a little harder, because next, to get full credit on this version, is similar, but return the number of items in that range. Now, hopefully you can see you do not need to search the entire binary search tree for count in range to work. Or I guess you could. Yeah, I wouldn't do that. Although you could also create your little count and range function to do in order traversal as well, with a special function. That might work as well. There are different ways to solve this problem. But that's the number. So in this example on the board, how many are between, what are we going to do, 2 and 15 inclusive? 4. Notice that you're going left, and once you hit a number that's not in range, you don't have, I guess you have to go to the right. But if 2 is that number exactly and we have no uniques, you don't need to go any further. Okay. Then make sure you do in order, which we talked about last time, and then also do pre-order and post-order. If you don't remember how to do those next 2, review the last lecture. It was pretty straightforward, I hope. And the last function, in order traversal, but this time notice I'm giving you a function pointer as a parameter, so it's going to do an in order traversal calling the function each time. Just like we did in class, where I wrote a function that called another function. This one is similar, except for as you do an in order traversal, you call the visit function. And this should be due a week from today. Great, October 30th. Is that when your ethics paper's due? Good, okay. Any questions? Comments? Screams? That was a pretty tired scream. Or maybe or apathetic scream? Nothing? Alright guys. Well, that's all for today. Assuming I will, of course, be here for lab time, and if you don't have anything else, I will see you next week.